Hello friends, welcome to our channel HTLT Electrical and Electronics Engineering. Today here I am going to discuss about the ratio error and phase angle error of potential transformer means PT. Brief description of potential transformer part 1. Here is the connection diagram of potential transformer. Here is the primary winding and here is the secondary winding. Here is the low ranges voltmeter are connected across the secondary winding, and here is the supply voltage, and here is the primary winding, and here is the load. Okay, next. The potential transformers are used for measurement of high voltages by means of energizing low range potential coils of voltmeters, wattmeters, energy meters. These are also used for energizing potential coils of relays and other protective equipment. The simple connection diagram for measuring high voltage by using low range voltmeter employing potential transformer is previously shown in figure 1. The voltage being measured acts across the primary winding, which has a large number of turns connected across the circuit. The secondary winding, which has a much smaller number of turns, is coupled magnetically through the magnetic circuit to the primary winding. The turns ratio is so selected that secondary voltage is 110 volts, whatever may be the primary voltage. The instrument burden of PT is almost 15 VA to 200 VA. Their MCB or fuse are used to the primary and secondary circuit of potential transformer for protection. For protection of PT from 3.3 kV, 6.6 kV, 11 kV, 33 kV, for the protection side of for protection of transformer in the primary side is given by only fuse. Okay, next. Here is the vector diagram for PT. VP primary voltage, EP primary induced EMF, IP primary current, RP resistance on primary side, XP reactance on primary side, VS secondary voltage, ES secondary induced EMF, IS secondary current, RS resistance on secondary side, XS reactance on secondary side, KT transformation ratio, KT transformation ratio, voltage transformation ratio, ES by EP. I0 no load current, I iron loss component of I0, Im magnetizing component of I0, KT voltage transformation ratio, ES by EP. Here is the VP primary voltage and EP is the primary induced EMF. Subtracting from VP vectorically IP, XP and IPRP. Similarly, here is the VS secondary voltage This will be obtained from subtracting ES induced secondary voltage EMF by ISRS and ISXS vectoretically. Here is IS secondary current and this is IS by KT is the secondary current referred to primary. The IP primary current, I0 is the no load current, and here is the two component of I0, IM and IE. IM means magnetizing component of I0 and IE is the iron loss component of IE is the iron loss component of I0. The viewer are requested when I show the equation, please match synchronously with this vector diagram by screenshot or by others method. Okay, next. The ratio error. Resolving all quantities along the KTVS axis, we get Vp cos beta is equal to KTVS plus KTIS RS cos phi plus KTIS XS sin phi plus IPRP cos theta plus IPXP sin theta, equation 1. Now in practice, since beta is very small, so cos beta equivalent to 1. So KTVS is very nearly in phase with EP. IP cos theta is equal to IE plus IS by KT cos phi. IP sin theta IE plus IS KT IS by KT sin phi. IP sin theta. Substituting these values in expression 1. Substituting the value in expression 1, we get Vp equivalent to KTVS plus KTIS RS cos phi plus KTIS XS sin phi within bracket IE plus IS KT cos phi into RP plus IM plus IS KT sin IS oblique IS by KT sin phi within bracket into XP is equal to KTVS plus IS by KT cos phi within bracket RP plus KT square RS plus IS by KT sin phi into within bracket XP plus KT square XS plus IPRP plus IMXP. KTVS plus ISKT RP dash cos phi plus ISKT XP dash sin phi plus IPRP plus IMXP, where RP dash and XP dash are the equivalent total resistance and total reactance respectively referred to primary winding. Actual voltage ratio Vp by Vs is equal to KT plus IS by KT into within bracket RP dash cos phi plus XP dash sin phi bracket closed plus IPRP plus IMXP divided by Vs. Actual voltage ratio. Percentage ratio error is equal to Kn Vs minus Vp by Vp into 100, where Kn is equal to nominal ratio, rated primary voltage to rated secondary voltage. The viewers are requested to see the vector diagram simultaneously and synchronously with this equation by screenshot or others method to understand it. Okay, next. Phase angle error. From vector diagram, tan beta is equal to AB by OA is equal to KT IS XS cos phi minus IP RP sin phi plus IP XP cos theta divided by KT VS plus KT IS RS cos phi plus KT IS XS sin phi plus IP RP cos theta plus IP XP sin theta is equal to KT IS into XS cos phi minus IPRP sin phi plus IPXP cos phi divided by KTVS. All other terms in the denominator are very small in comparison with KTVS and so can be neglected. Since beta is very small, so beta is equal to tan beta. Okay, this is all for ratio angle and phase angle error for PT. If you think the video is useful to you, please subscribe my channel and share it to your friends. The next topics will be the PT part 2. Thank you for watching the video. Okay, bye. See you again.